Hello, chào các em. Hôm nay thì thật là thầy cũng rất là mệt, cho nên là chúng ta có thể coi một giờ tự học nhé. Thầy cũng không nói được nhiều. Thì thầy sẽ cho các em xem một số cái đoạn video về an ninh mạng. Chúng ta xem một đoạn video về cái việc phát hiện cái phương thức tấn công ARP poisoning hay là spoofing ấy, mà chúng ta đã nói hôm trước. Thì cái này thì chắc là họ dùng cái phần mềm.
Right, so let's talk about how we can detect.
Họ sẽ có một phần mềm nhưng chắc là họ vẫn dùng cái phần mềm mình trước. Chúng ta nói là cái phần mềm XARP đấy. XARP.
ARP poisoning attacks. First of all, let me show you the ARP table. So in our Windows device, which is the device that we always attack, I'm going to run a command ARPA to list all the entries in the ARP table. So each computer has an ARP table.
Là mỗi máy tính thì đều có cái bảng ARP để lưu giữ địa chỉ IP và địa chỉ MAC chúng ta nhìn thấy. Đây là trong Windows này. Để các bạn gọi lệnh ARP A, tức là nó sẽ liệt kê những cái địa chỉ ở trong cái bảng này.
And that table associates IP addresses with MAC addresses. So we can see the IP address of the router, which is 10.20.14.1, is associated with the MAC address 52.54, and it ends up in 30.
Các bạn chú ý nghe, tại vì cái phụ đề nó không chính xác lắm đâu. Cái phụ đề nó chế ra bằng cái công nghệ của Google dịch ấy, giống như là dịch Google, cho nên là nó không thực sự chính xác.
500. So this is the MAC address for the IP for the router. So the way that ARP poisoning works, like we discussed before, is it works because each request is trusted and clients accept responses even if they didn't send a request. So what the hacker does is he sends a response to the client telling them that they are the router. So the client will accept that, it will trust it, and it's going to accept the response even.
Như trước chúng ta nói thì kẻ tấn công hacker thì nó sẽ gửi những cái bản tin response ARP, bản tin trả lời ấy. Bản tin response là bản tin reply đến tất cả những cái hot trên mạng, đúng không? Thì ví dụ như là gửi đến cả victim này, gửi đến cả SharePoint, thông báo là cái địa chỉ của nó là địa chỉ của nạn nhân và đồng thời là địa chỉ của SharePoint, đúng không? Vì nạn nhân thì nó bảo nó là router, tức là 10.0 10.0.2.1 ở đây, là ví dụ này như vậy. Còn phía SharePoint thì nó bảo là nó có địa chỉ của nạn nhân, tức là 10.0.2.7. Như vậy là nạn nhân sẽ thông qua hacker để đi vào SharePoint, từ đó mới ra internet. Và như vậy hacker đây đóng vai trò là man in the middle, tức là người ở giữa. Cái này em biết ta nói rồi, và tôi đã làm ví dụ ở trên cái mạng nhà tôi rồi, đúng không? Qua cái điện thoại chúng ta vào cái máy Kali Linux, sau đó là mới vào cái router để ra internet.
though it didn't send a request. Then we'll send another response to the router telling them that we are the client. So what this is going to do, it's going to modify the entries in the ARP tables in both in the router and in the client. And for the client, it's going to contain the hacker's MAC address, and it's going to associate that with the router's IP address. So what's basically going to happen is it's going to modify the MAC address here, and it's going to change that to the attacker's MAC address instead of the router's real MAC address. So when that happens, then the hacker will be in the middle of the connection, and they'll be able to read, analyze, and modify the packets because they're going to be flowing through the hacker device. So let's run the ARP poisoning, a normal ARP poisoning attack like we always do it. And when I go back here, I'm going to execute the same command. So I'm going to do an ARPA again. And note how the MAC address is going to be different. So the MAC address for the router, it used to be this one. And when we ran the command, then the MAC address changed to this one. And this MAC address right here is the MAC address of the network card that the attacker is using. So if I come here and just do an ifconfig, you'll see that this is the MAC address, the same MAC address that is displayed in here. So this is the easiest and the simplest way to discover ARP poisoning attacks. It's not the handiest way though, because you're gonna have to keep doing this command and keep comparing the entries if you really wanted to check if you're.
Ở đây tác giả nói là bằng cách so sánh cái bảng ARP trước và sau khi bị tấn công thì chúng ta có thể thấy là sự khác biệt về địa chỉ IP, ví dụ như cái địa chỉ 14.1 này, thì địa chỉ MAC nó khác đúng không? Như vậy là có thể phát hiện ra tấn công ARP poisoning được. Nhưng mà chúng ta cứ phải so sánh liên tục như vậy thì rất là mất công, không thể làm thủ công như vậy được.
Being ARP poisoned. So there's a tool called XARP, and it does that automatically for you, and it's available for Linux and Windows. So I already downloaded. You can just Google XARP and you can download it. Very easy to download and install. And I'm just going to run it. I'm actually going to stop the attack first, and then I'm going to run the tool. Now notice when you stop the attack, the IP address is going to go back to what it was. So you can see that the MAC address of the router is back to its default right value of the router. So I'm just going to run XARP now. And you can see that everything is good. And you can see that the entries are very similar to what we did when we did ARPA. So we have the IP addresses and the MAC addresses associated with it. What the tool basically does, it's just going to automatically monitor this. And whenever something changes, it's going to know that something's wrong is happening because each IP address should have a unique MAC address. There should be no duplicates in the network. So I'm going to do another ARP poisoning attack exactly like we did it before. And when we come here, you'll see that XARP is giving us a notification and telling us that something's happening. It's telling us that the MAC address for the router, which is the 10.20.14.1 IP, has changed from this to that. And if we look here, I'm going to click OK. And if we look here, we can see that the affected machines are the router, my own machine right now, and the attacker. Sorry, that's me, and that's the attacker. So basically, we know that the machine at 10.20.14.203 is trying to do an ARP poisoning attack because it's the one that the router's MAC address has changed to. Therefore, we know this is the attacker machine. So this tool is really handy because it does the monitoring automatically for us, and it will tell us whenever someone is trying to ARP poison the network.
Như vậy chúng ta thấy là ở đây người ta trình bày cái cách mà phát hiện ra tấn công ARP poisoning. Có thể theo dõi một cách thủ công cái bảng ARP, hoặc là chúng ta dùng việc công cụ XARP để theo dõi và nó tự động đưa ra cảnh báo.
Okay, so now let's see how we can use Wireshark to discover suspicious activities in our network. And before I do anything, I'm going to go to the preferences. And I'm going to go to protocols, ARP. And I'm going to enable the option to detect ARP request storms. What this will do, it'll actually discover if anybody is trying to discover all the devices on the network, and it's going to give me a notification. So I'm going to click on OK, and I'm going to start my capture. And now I'm going to go to my Kali machine, and I'm going to use net discover. So I'm not going to do ARP poisoning. I'm only going to try to discover all the connected devices to my network. So we're using exactly the same command that we used before, net discover, interface, and the range. I'm going to hit enter.
Cái lệnh net discover trong Kali Linux thì chúng ta biết là nó sẽ gửi đi những cái bản tin ARP để nó khám phá các máy trên mạng, nên gửi đi bản tin quảng bá để nó tìm ra các máy trên mạng. Thế thì ở trong OSAC chúng ta thấy là nó cũng có cái tính năng để có thể phát hiện ra những cái bản tin như vậy. Như vừa rồi tác giả vừa cho chúng ta xem trong phần reference thì nó có tính năng để phát hiện ra những cái bản tin ARP. Thì chúng ta vào đó chúng ta xem, chúng ta kích hoạt cái tính năng đó lên.
And we can see that net discover finished. It discovered all the devices that we have. So if we come here, even before we look at the output of the notifications, let's just look at the packets that have been generated. You can see that there's a device here. This source is broadcasting. So basically it doesn't have a destination. It's asking all the other devices in the network, and it's inquiring about each possible IP. So it's basically asking who has this IP and tell the 67 IP. And then it's asking who has the 241 IP, tell the 67. Who has the 251, tell the 67. And it's doing this for every possible IP. So it's basically checking if any possible IP in the range exists, and it's asking to return the response to the IP at 10, 20, 14, 67. So from this, we can deduce that someone is trying to discover all the connected devices.
Các bạn thấy là ở trong cái cửa sổ mà tác giả trình bày thì một cái máy nó gửi rất nhiều bản tin yêu cầu để tìm ra địa chỉ IP và địa chỉ MAC của con máy ở trong một mạng LAN. Như vậy đó chính là cái dấu hiệu nghi ngờ là một cái máy nó đang có dấu hiệu là nó đang dò tìm các máy trên mạng, hay scanning bằng ARP, đúng không?
And that someone is at 10, 20, 14, 67. Now, if we go on the analyze and expert information, you'll see that we detected an ARP packet storm. So basically it means that there was a single device sending a very large number of ARP packets. So they're probably trying to discover connected devices or trying to discover connected ports. So it's telling us that this person is trying to do something suspicious. Now let's go, and I'm gonna do a ARP poisoning attack.
Các bạn thấy là từ nãy giờ tác giả toàn dùng Bettercat để gửi các gói tin spoofing, đúng không? Còn cái caplet này thì không biết chúng ta chưa nói, thì đấy là một cái file kịch bản. Thay vì chúng ta phải gõ từng lệnh trong Bettercat thì chúng ta có thể xác định một chuỗi lệnh cho Bettercat trong một cái file là caplet, trong một file caplet. Cái file này chúng ta có thể lập trình được, tức là lập trình nó đơn giản thôi, nó thứ tự từng bước một, sau đó chúng ta đưa vào trong cái file này. Và lần sau chúng ta chỉ việc load lại cái file bằng cái tham số caplet thôi, sau đó chỉ ra cái vị trí của cái file đó.
And we'll see if we can get any notifications or warnings in Wireshark. Now I'm going to go to Analyze and Expert Info again. And if we look, we'll see we have a warning here. And the warning is telling us that there is a duplicate IP address configured. So again, this is telling us that the IP address of the router had two different MAC addresses. What this means, basically, it means that someone was tampering with this and tampering with our ARP table, trying to place themselves in the middle using an ARP poisoning attack. Now, we've seen a number of methods to detect ARP poisoning. Let's discuss how we can prevent it or protect ourselves from it. Now, I'm just going to run an ARPA, and we're going to look at our table. There is switches that will monitor this for you as well, and they'll notify you or even prevent ARP poisoning attacks. Another way to do that is, if you look at here, if you look at your router, you'll see that this entry in the table is dynamic. So the type of this entry is dynamic. What that means, it basically...
Cái bảng này các bạn thấy là trong cái bảng ARP thì nó có chữ dynamic. Dynamic là nó học một cái động.
This can change. It's the system allows this value to be changed. You can see right here, you have static values, which basically means the system.
Còn có một số cái dòng thì nó là static, tĩnh. Thì cái tĩnh này thì nó là cố định. Còn dynamic là động thì nó có thể thay đổi. Cho nên là chúng ta đặt những cái tham số nào là tĩnh thì nó sẽ không thay đổi được. Như vậy nó sẽ bảo vệ trước những tấn công kiểu như là ARP poisoning. Ví dụ như cái tham số 14.1 này là của router. Các bạn đặt nó là static thì nó sẽ không thay đổi được bởi hacker.
System will never allow these values to change. So you can use static ARP tables, which basically means that you'll have to configure each IP address. So you have to actually configure your ARP table and map each IP address to the MAC address, to the relevant MAC address. But once you do that, even if someone tries to send a response to your computer trying to change it, the system will refuse to change anything because you configured your ARP table to be static. The only problem with that is every time you connect to a network and every time there is a new device connecting to your network, you'll have to manually configure that device to work with your network. So it's not a very useful solution if you're in a big company or if you're in a big firm, but maybe in a small house or in a small company, then this would be a really good solution to prevent ARP poisoning attacks, because everything is going to be static. You're going to have to set it up manually. But when someone tries to do an ARP poisoning attack, even if their attack is successful and they use the best tools they can, your table is set up in a way that it's fixed. It can't be changed. So the system will always refuse to change the values of the MAC addresses, which will basically mean ARP poisoning attacks will never work against you.
Trong Windows thì chúng ta muốn add một cái tham số vào cái bảng này mà ở dạng static thì các bạn thêm cái khóa P, gạch P một cái thì nó là persistent, nó sẽ luôn là static.
In the previous lectures, we learned how to detect ARP spoofing attacks by manually analyzing the ARP tables. We also learned how to install tools such as XARP to automatically detect ARP spoofing attacks without having to manually check the ARP tables. And we even learned how to detect other suspicious activities using Wireshark. Now, this is really good, but still has a few problems. First of all, we're only talking about detection. So even when we detect that someone is intercepting the connection, we can't really do much. All we could do is simply disconnect from the network, maybe change its password if we can, if we own the network, to something that's more difficult, or if this is a public network such as an airport, a hotel, or a college network, then all we can do is simply just disconnect and use a different network because we can't change its password. The other problem with the previous methods, like I said, they're only detection methods. Therefore, they'll only work if the target managed to become the man in the middle using ARP spoofing. But what if someone is able to intercept the connection using another method? For example, if someone is running a fake access point, like I showed you earlier, and you connect it to this fake access point. or if you connect it to a hotel, a college, a public Wi-Fi network, a cafe network, and the admin of that network is actually collecting data, or someone.
Ở đây tác giả bảo là nếu mà hacker không tấn công bằng ARP positioning mà có thể thông qua một cái phương thức khác, ví dụ như là thiết lập một cái mạng Wi-Fi miễn phí, public, dành cho mọi người dùng và thu thập dữ liệu của mọi người thông qua cái Wi-Fi đấy, thế thì chúng ta cũng không tránh được, đúng không? Tức là dữ liệu nó vẫn qua cái router đấy và nó vẫn bị capture, file có tin vẫn bị capture. Thế thì chúng ta sẽ làm như nào? Thì thông thường là chúng ta nên áp dụng cái biện pháp bảo mật là mã hóa dữ liệu.
Or a hacker gained access to the admin's computer and again is analyzing the data, because by default in fake networks and in any network, the admin is able to see the traffic because the traffic will have to go through their server or through their router. So the detection methods that I showed you earlier won't even work against this. Therefore, in this lecture, I want to discuss two solutions to this problem. So the idea is you use these solutions if you discover that you're being attacked, or if you're connecting to a network that you don't own and manage yourself. So if you're connecting to a college network, an airport network, a cafe network, or any other network that you yourself don't have control over. The solution to all of this is to encrypt your traffic. If you encrypt your traffic, we don't really care if somebody is able to intercept this traffic, because our traffic is going to be encrypted, therefore it'll be gibberish and it won't be useful to anybody that is intercepting our traffic. So there are a number of ways to do this, and I'll explain how they work as we go through it. So let me show you this in action. Right here, I'm already running BetterCap, and as you can see, it's already getting information. And right here is my target, and we're already on VulnWeb. And if we just click on anything just to show you, you'll see the domain is going to be detected in here. And then let's just quickly log in. You'll see this login attempt will be detected. So we have the username is admin and the password is test. Again, if we try, I'll just open a new tab and go to Stack Overflow. You'll see it'll load over HTTP, not HTTPS. So again, if I go ahead and log in, I'll be able to log in and detect the password. And the HSTS method that I showed you earlier, again, it'll work and we'll be able to bypass that and steal the password. So right now, this Kali machine is able to intercept all the data that is sent to and from my Windows machine right here. So the first method to prevent these attacks, so we don't care if we're being attacked. Again, I'm not running XARP, I'm not managing my ARP tables. I don't care if someone intercepts my data. What I'm going to do is I'm going to install a plugin on my browser called HTTPS Everywhere. So I'm going to be installing it on Firefox. I'll include its link in the resources of this lecture, but there is an equivalent of this plugin for most browsers such as Chrome and others. All you have to do is simply click on Add to Firefox or Add to Browser, whatever browser you use. We're going to click on Add in here. And that's it. The plugin is added in here. As you can see, we're going to click on OK. And we can manage it here from its icon on the top right. So as you can see right now, it's set to off. And if I click this, I will turn on this plugin. And basically what this plugin will do, you can think of it as if it adds HSTS support to more websites, pretty much to any website that uses HTTPS. Therefore, for example, when I tried to access Stack Overflow in here, I was able to downgrade it because my browser does not know that this website should be loaded over HTTPS, and BetterCap was downgrading the HTTPS requests to HTTP. Like I explained in previous lectures. What this plugin will do, similar to HSTS, it has a list of websites that support HTTPS, and therefore, when we try to downgrade the HTTPS connection of this website to a HTTP connection, it'll tell the browser, no, don't do that, and it will upgrade it again back to a HTTPS connection. So let me show you. I'm just going to delete the history and I'm going to load Stack Overflow again. And perfect. As you can see, it's loading with HTTPS in here. Therefore, now if I go and log in, my information will be encrypted and therefore the hacker won't be able to see my username and password. So that's really, really good, but not perfect. Let me tell you why it's not perfect. First of all, if we go back to a HTTP website, again, similar to what we have in here in VulnWeb, so I'm just going to log out. And we'll log in again with another password. I'll just put the password now to 12345678990. We'll log in. And if we go back here to the logs all the way down, you'll see we are still able to detect the username and the password. So this plugin is really good for websites that support HTTPS. It'll force us to load HTTPS on websites that support HTTPS.
Như vậy các bạn thấy là ở đây thì chúng ta cài một plugin vào trong trình duyệt, có thể là Firefox. Cái plugin vừa rồi nó tên là HTTPS Everywhere, thì nó có thể cài đặt trong các trình duyệt ở dạng plugin, thì nó sẽ buộc cái kết nối đến cái server, cái máy chủ web ấy, nó luôn là cái giao thức HTTPS là mã hóa chứ không phải là HTTP. Nhưng mà nó không phải là perfect, tức là nó không phải là hoàn hảo, bởi vì có những cái website nó chỉ hỗ trợ HTTP, ví dụ như là cái trang này đúng không? Chúng ta vừa nhìn thấy là cái trang này nó chỉ hỗ trợ HTTP thì sao?
Yes, but if you access a website that only uses HTTP, such as
nếu mà chúng ta truy cập website mà chỉ hỗ trợ HTTP, tức là HTTP không có cái phiên bản mã hóa như cái trang này, thì làm sao? Ở đây bảo là hiện nay thì ít website mà nó chỉ HTTP mà không HTTPS. Và hiện nay thì rất ít website như vậy, nhưng mà vẫn có. Vẫn có.
As VulnWeb, I know there aren't a lot of websites that do that, but they still exist. So if you access any website that uses only HTTP, then that website is still open to the hacker. So the hacker can still see this information. They'll still be able to steal usernames and passwords if you send usernames and passwords to them. Not only that, but they will also still be able to replace downloads, serve you fake updates, or inject JavaScript code like we seen earlier and get you hooked to beef. HTTPS Everywhere also does not prevent the hacker from seeing the websites that you access and running DNS spoofing attacks. Let me show you. So if I just go to bing.com, for example, and then let's go to duckduckgo.com. Keep in mind, HTTPS Everywhere is still working. And let's go to the hacker machine and just look at our logs. So as you can see, we can still see that our target went to DuckDuckGo. We can still that the target went to Google. We can see that the target went to Bing. So we can still see the domain names, but we can't see the data that gets sent because that will be encrypted with HTTPS. So there is still some data that the hacker is able to get. If you want to take your security to the next level and completely encrypt everything you send and receive, then you should think about using a VPN.
Ở đây các bạn thấy là nếu mà chúng ta sniffing có thể dùng Bettercap hay là dùng cái gì đó để sniffing thì vẫn nhìn thấy cái domain, cái dữ liệu của người dùng, username, password, vân thì không nhìn thấy nữa bởi vì nó bị mã hóa rồi. Tất nhiên phải giải mã, nếu mà cái key nó lấy được thì nó vẫn giải mã được, nhưng mà cái điều đó thường rất là khó. Nhưng mà nó vẫn nhìn thấy cái domain, cho nên là nếu mà muốn encrypt, muốn mã hóa toàn bộ tất cả luôn, cả cái domain này, thì chúng ta có thể dùng cái mã riêng ảo là VPN.
Therefore, in the next lecture, I'll explain to you what a VPN is, how it works, and how it can protect us from hackers or anybody that intercepts our connection.
Chúng ta nói sang cái cách mà sử dụng VPN để
In the previous lecture,
bảo vệ dữ
we
liệu.
discussed a good solution to protect us from man in the middle attacks, and that solution was to use HTTPS Everywhere plugin. With this plugin, as seen earlier, we were able to force all HTTPS websites
Các bạn chờ chút nhé. Chờ thầy tí nhé.
use HTTPS Everywhere plugin. With this plugin, as seen earlier, we were able to force all HTTPS websites to always load over HTTPS. Therefore, if anybody intercepts our data, it'll be useless because it'll be encrypted with HTTPS. So, this solution is really good. It's free. The only problem is, as you know, it only works with websites that use HTTPS. So we seen earlier, if you log in or use a HTTP website, your data is still exposed. Hackers or anybody that intercepts your data is still able to read your usernames, your passwords, or inject JavaScript code, serve you fake updates, and so on. Also, as seen earlier, with this plugin, the hacker or anybody that intercepts your data will be able to see the websites that you visit. Not only that, but they'll also be able to manipulate DNS requests, and therefore they'll be able to run DNS spoofing attacks. At the end of the previous lecture, I said if you want to take your security to the next level, then you should think about using a VPN. Let me show you what happens when we use a VPN, and then I'll explain it in more details to help you understand what's happening. So I'm back here at my hacker machine. As you know, it's already the man in the middle. I'm going to clear the screen, and I'm actually going to even turn off HTTPS Everywhere. Now, it's a good idea to use both at the same time, but I'm just going to turn it off just to show you the difference. You can use any VPN provider you want. It really doesn't matter. Most of them use more or less the same technologies. We at Z Security provide our own VPN service called ZSVPN. So I have it right here. It comes with no logs. We support all operating systems, Linux, Windows, OS X, Android, and iOS, and even Tails, which is a privacy-focused Linux distro. So, like I said, you can use anything you want. They all use more or less the same technology. What I want to highlight right now is what happens when you actually go ahead and use a VPN. So I'm going to open my client and I'm going to connect to a server, one of these servers right here. And what this will do is it'll establish an encrypted tunnel between my computer and the VPN server that I just connected to. Therefore, right now, let me show you. Let's just start. I'll delete everything. And let's start by going to some websites. For example, we'll go to google.com. Then we'll go to bing.com. And then let's go to Stack Overflow and make sure it loads over HTTPS. Now, keep in mind, I am not using HTTPS Everywhere. But you'll notice that it'll still load over HTTPS. As you can see, we're not able to downgrade it. And let's take this even one step further. Let's go to vulnweb.com and just log in. So again, this is a website that only uses HTTP. It simply does not support HTTPS. But let's log in and see if we can still capture the data. So I'll just put my password now, 0987654321. Log in. And let's go back to our Kali machine to see if we detected anything. Now, as you can see, we're not able to read any of the traffic sent to and from the target. So with the case when we used HTTPS Everywhere, we were able to see at least the domains, the websites that the target visited, and we were able to see data sent over HTTP when we logged in to vulnweb.com. But in this case, as you can see right now, we can't see the username and the password even if they're sent over HTTP to vulnweb, and we can't see the domain names that the target visited. And the reason for this is because we are using a VPN, and like I said, a VPN creates an encrypted tunnel between our computer and a server, and all of our data will be sent through this encrypted tunnel. Let me explain this to you with diagrams to make it simpler. So in general, let's say you try to go to google.com. Your connection will pass through a number of hops, but at the end, it's going directly to google.com. Hence the red arrow indicating that this connection could possibly not be encrypted, therefore your data might be at risk. Now, when you use a VPN, you connect to a VPN server in a certain country. And when you do that, you create an encrypted tunnel between your computer and the VPN server. So let's say you want to go to google.com. That request will first be sent to the VPN server. Now, the VPN server will be able to read this, but the data is sent in an encrypted tunnel. Therefore, if anybody intercepts this data, they will not be able to see what you are sending to your VPN server. That's why we don't even care if someone manages to intercept our connection, because our data is simply gonna be gibberish to them, as you can see in.
Thì các bạn thấy là cái công nghệ mạng riêng ảo VPN này thì khi người dùng kết nối vào internet thì đầu tiên là người dùng sẽ kết nối vào VPN server của nhà cung cấp dịch vụ VPN, và cái kênh này được mã hóa, cho nên là những cái dữ liệu, kể cả domain, tất cả mọi thứ nó đều được mã hóa thông qua cái kênh này. Chúng ta gọi là kênh hay là cái đường hầm tunnel. Tunnel tức là cái kênh hay đường hầm kết nối giữa user và VPN provider, nhà cung cấp. Thế thì do tất cả được mã hóa cho nên là chúng ta khá là an tâm khi mà kết nối thông qua cái kênh này, mọi thứ đều được mã hóa. Thì sau đó từ VPN server này họ mới kết nối đến cái dịch vụ mà chúng ta muốn vào, ví dụ google.com, những dịch vụ mà các bạn muốn vào thì sau đó mới được từ VPN server này kết nối đến. Cho nên chúng ta cũng thấy nó gần giống như là proxy server, nhưng mà ở đây thì cái đặc điểm của VPN đó chính là cái việc mã hóa rất là an toàn.
Here. Then, once the VPN server receives your request, it will forward it to the destination that you're requesting, and the response will follow a similar route. Now, because of this structure, because of the way that the data is always encrypted between you and the VPN server, using a VPN can be useful in so many scenarios, because it adds an extra layer of encryption. Therefore, it improves our privacy and anonymity in general. It allows us to bypass censorship, because let's say your internet service provider is preventing you from accessing certain services or certain websites.
Ở đây thì VPN nó còn rất hữu ích khi mà chúng ta muốn vào những dịch vụ mà nó bị ngăn cản. Ví dụ các bạn ở Trung Quốc nhỉ, thì Trung Quốc ngăn cản vào Facebook, ngăn cản vào những cái dịch vụ mà họ không cho phép vào. Người dân Trung Quốc là không được dùng dịch vụ đó. Thì bằng cách sử dụng những VPN server này chúng ta vẫn có thể vào được, vẫn có thể đấy nhá, chưa chắc là vào được đâu. Vì nếu mà cái máy chủ VPN này nó cũng bị chặn luôn ở Trung Quốc thì chúng ta cũng không vào được. Cái này là có thể thôi chứ chưa chắc là vào được.
Websites, they will not be able to know what these websites and these services are, because again the connection is encrypted and they won't even know what you're doing. All they'll see is that you're connecting to a server in some country. And last but not least, it'll also protect us from hackers or anybody that intercepts our connection, again because all of our data is encrypted. Therefore, we don't really care who intercepts this data. The data will be gibberish. Now, also because of this structure, you need to be careful when you pick a VPN provider, because this structure introduces the VPN provider as a man in the middle. So as you can see, we send everything to the VPN server first, and then it goes to the internet. And the VPN server is able to decrypt this data.
Tác giả đây muốn nói là cái VPN server và provider này nó có khả năng là biết chúng ta làm cái gì. Tại vì ở đây nó sẽ giải mã dữ liệu của chúng ta, đọc được hết thông tin. Cho nên là nếu mà chúng ta lựa chọn một nhà cung cấp dịch vụ VPN thì chúng ta phải lựa chọn cái dịch vụ nào nó đáng tin cậy, chứ không nên là lựa chọn những cái dịch vụ mà nó chúng ta không biết trước là người ta có uy tín hay là có thực sự là an toàn hay không. Ví dụ như dịch vụ VPN free thì tốt nhất là không nên dùng.
because the tunnel, the VPN encryption, is only used between our computer and the VPN server. So if the admin of the VPN server wanted to analyze your data and see what you send and receive, they will be able to do that. Therefore, you need to make sure that you pick a reputable VPN provider, a company that you can trust. You want to stay away from free providers because providing a VPN service is very expensive. Therefore, if someone's able to give it to you for free, they must have another angle or another reason of why they are giving this for free. You want to make sure that the VPN provider keeps no logs. And with all of that, you can use HTTPS Everywhere plugin with the VPN. If you do that, you will actually fix the problem of the data leaving the VPN server, because your data will be encrypted between your computer and the VPN server with 2 layers of encryption. First, using the VPN encryption, and second, using TLS because of HTTPS Everywhere. Then, data leaving the VPN server will be encrypted with 1 layer of encryption, which is the encryption enforced by HTTPS Everywhere. Therefore, even though the VPN provider is able to see your data and able to decrypt the encryption used in the VPN tunnel, they will still not be able to see your data because it will still be encrypted with TLS. So this basically solves the problem of the VPN server being able to see your data, because at the VPN server, your data will still be encrypted with TLS. So to summarize the 2 methods that we covered to protect our data from man-in-the-middle attacks, with HTTPS Everywhere, it's great, it's free. The only problem is it only works with HTTPS websites. The person intercepting the data will still be able to see the websites we visit, and they will still be able to run DNS spoofing attacks. Then we spoke about using a VPN, and with using a VPN, everything gets encrypted, so that's even better. None of the attacks that we talked about and that we covered in this course will work because everything gets encrypted. The only problem is it's not free. There are free services, but like I said, they're not great, so you shouldn't use them. Just don't use a VPN if you don't want to pay for it. The other problem with the VPN is that the VPN provider can't see your data, so you're introducing a man in the middle. But we can take this one step further and use HTTPS Everywhere with a VPN, and with that we're getting all of the benefits of using a VPN, so everything gets encrypted, protect us from all man in the middle attacks, but without the problem of the VPN provider being able to see our data, because our data will be encrypted with 2 layers. Therefore, even the VPN provider will not be able to see what we send or receive because it'll still be encrypted with TLS. So the only downside to using HTTPS Everywhere with a VPN is the fact that you have to pay for the VPN service.
Vậy thì là dịch vụ VPN thì nó rất là hay, nhưng mà nó thường là không miễn phí. Mà nếu mà miễn phí thì chúng ta cũng tránh dùng, bởi vì nó cũng không an toàn. Giờ chúng ta nói sang một cái khác. Và xem lại cái phần chương này. Cái này chúng ta biết rồi. Mình nhắc lại một chút về beta cap vậy.
Now, in this lecture, I want to show you how to run an ARP spoofing attack using BetterCap. This will allow us to place our computer in the middle of the connection and intercept data. Not only that, but we're also going to see how we can read this data, so we can see all the URLs and all the websites that the target visits, and we'll see everything that they post. So anything, any usernames, any passwords they send to any websites, we're going to be able to capture them and see them. So First, we need to become the man in the middle, and we're going to do this using a module called ARP spoof. So if I scroll up to the help menu, you can see we have a module here called ARP spoof. So as usual, if we don't know how to use this module, we're going to do help arp.spoof because we want to see how to use this module and see all the options that we can set for it. So as you can see, as usual, we can do ARP spoof on to turn this module on. We can do arp.ban on, and this will literally just cut the connection of the target. This is very simple. You can try it on your own time. I'm not going to do it here. You can do ARP spoof off to turn it off, and arp.ban off to turn the ban off. Now, in the previous lecture, I also said anything you see under the parameters.
Cái ban mode này của ARP spoof module ấy, thì nó là cái chế độ mà nó làm cho cái kết nối của người dùng bình thường ấy. Chúng ta spoof là giả mạo một cái người nào đó đúng không? Nhưng mà cái chế độ ban này tức là làm cho người đó không vào được internet nữa, nó sẽ không ra được gateway, không vào được internet. Cho nên là ngày trước không biết bạn nào dùng cái phần mềm nó có cái phần mềm ARP, tôi không nhớ cái tên nó là cái gì, internet off hay gì đó. Nên là cái phần mềm đấy nó thực ra nó chính là cái chế độ ban này của ARP spoofing này. Thì nó sẽ ngắt kết nối internet của người dùng mà chúng ta không dùng internet, là vì như vậy.
Are the options that we can set for this specific module, but I didn't show you how to modify that. So in this lecture, we're actually going to be modifying some of these options. Now, as you can see, the tool is actually very helpful because first of all, it's given us the option name in yellow here. So these are the options that we can set, that we can change. And then it's also telling us a description of what this option does and the default value. So for example, we can see we have an option called arp.spoof.fullduplex. You can see the description for this option, and basically what this option will do, if you set it to true, it will spoof both the router and the target. So it's similar to what we did with ARP spoof when we executed the command twice to spoof both the router and the target. So if you set this to true, both the router and the target will be spoofed and you will be in the middle of the connection. If you leave it to the default, which is false, you will only spoof the target machine. Now this can be useful if the router has some sort of protection against ARP spoofing attacks because you won't be interacting with the router at all. But it's also limiting because we won't be able to do what I'm going to do in the next lectures because the router will communicate with the target device directly, so we won't be able to inject stuff in the responses that the router sends to the target device. Now, I actually want to change this to true, and the method I'm going to do this can be used to change any option in any module in BetterCap. So not only in the arp.spoof, if you're using any module, you can do help followed by the module name to get help about that module name. You can see all of the options that you can set in here. And then if you want to modify the value of any of these options, all you have to do is copy the option name, which is what I have right here, and type set followed by the option that you want to modify. And in my case, it's called arp.spoof.fullduplex, and I want to set this to true. So very, very simple. And like I said, you can use this command to change any option in any module in BetterCap. All you have to do is type set, followed by the option name, followed by the value that you want to set. So I'm going to hit enter, and that's done. If you don't see errors, that means it got executed properly. The next option that I want to change is the targets. So again, in the description, it's telling us that these are the targets that I want to run the attack against. And I can use a comma if I wanted to target more than one IP at the same time. So again, just like what I did before, I'm going to do set, followed by the option name, which is arp.spoof.targets. And you can actually use the tab to autocomplete. So if I just type TA tab, it'll autocomplete the targets for me. And after this, I'm going to put the value that I want to set this option to, which is the IP of my target. And we can get this using NetDiscover, using ZenMap, or using the result that I got in here. After I run the recon module, I did net.show, and we got all of this, which is the list of all of the computers connected to the same network. And my target right now is this particular device, the 10027. This is my Windows virtual machine right here. So I'm going to put the IP 10027. And again, we don't see any errors, which means that everything got executed as expected. Now we're ready to run the tool. And again, based on the help menu that we got, we can do ARP spoof on to turn this module on. So we're going to do arp.spoof on. And perfect. As you can see, we see no errors. It's telling us that the module is running. And if I do help, again, we're going to get a list of all of the modules that are running right now. And as you can see, we can see that ARP spoofing is on. Also, it is very important that you make sure that the net.probe and the net.recon are running. We did this in the previous lecture. That's why I didn't do it now. So right now, BetterCap should be doing what ARP spoofing was doing, fooling both the router and the target device and putting me in the middle of the connection as shown here. So let's go to the Windows machine right here, and I'm going to do ARPA. And as you can see, the router's MAC address right here is the same as the MAC address for this device, which is the 10.02.15. And if I go back here to the Kali machine and do ifconfig, you'll see this is the same MAC address as the MAC address of the Kali ETH0 interface. So basically what this means is this Windows machine, every time it wants to send something to the router, it'll send it to the Kali machine. And because we set the full duplex option on in BetterCap, the router also thinks that this Kali machine is the target machine. Therefore, anytime it needs to send a response to the Windows machine, it'll actually send it to BetterCap right here. And like I said before, this means every username, password, URL, anything the target computer sends or receives will have to go through the Kali machine, where we're going to be able to read it, modify it, or drop it. And I'm going to walk you through that in the next lectures.
Chúng ta thấy là xem lại cái module và những cái option ở trong BetterCap với ARP spoof để mình đã biết rồi, thôi thì nhắc lại.
In the previous lecture, we learned how to use BetterCap to run an ARP spoofing attack and place ourselves in the middle of the connection between a computer and the access point. And every time I do this, I keep saying this means that all the requests and all the responses will flow through our computer, which means that we'll be able to see anything a user does on the internet. So we should be able to see the URLs, the images, the videos, the passwords they log in with, or anything they send or receive. So right now, we are already in the middle of the connection, and this data is already flowing through our computer. So all we have to do is just use a program to capture this data and analyze it. Now we can use Wireshark to do that, and I will cover this later on in the course. But for now, I'm going to use a really nice module that comes with BetterCap that will automatically capture all of this data analyze it and show me the interesting stuff. So all we have to do now is to tell BetterCap to capture all of the data that is flowing through this computer and analyze it for me. And to do this, we can use the net.sniff module. So you can do help followed by net.sniff to see all of the options that you can set for this module. But I showed you how to read options and change them. So for now, I actually want to run it without modifying any of the options. So I'm just going to do net.sniff on. So now everything that's going to flow through this computer will be captured and analyzed by the net.sniff module. So I'm going to close this terminal window and let's go to the target Windows computer. I'm going to open my web browser and we're going to generate some traffic and see if that's going to be captured by BetterCap. What we're doing right now will not work against HTTPS. But don't worry, we'll talk about how to bypass HTTPS later on and why this won't work. But for now, for testing, I'm just going to go to a website called VulnWeb. And I'm going to include its link in the resources of this lecture. So as you can see, this is a normal website that doesn't use HTTPS. It also has a number of links here. So if I click, for example, on this link, everything is loading fine, as you can see here. But if we go to the Kali machine, you'll see that every request that we sent was actually captured by this computer. So you can do this to any computer that is connected to the same network as you, whether it's a wired or a wireless network. So you can see there were requests sent to Google. If we scroll down, you'll see we made a request for this website, vulnweb.com. You can also see all of the other files that this website loaded. So you can see we have a logo loaded here. You can see we have a styles file being loaded here. Again, if there were more images, you'll actually see links to all of the images that are being loaded. You can see here, this is the second link that we clicked on, the testphp.vulnweb.com. So this is what we have right here in the top. Now also, let me just go back and maybe click on the first one. And as you can see, this is another website. It has a login functionality in here. And let's try, for example, log in with a username. Let's set the username to my name, Zaid Sabi. And let's put the password as 12345678990. I'm gonna click on log in. Again, as you can see, we got logged in, no issues at all. But if I go back to the Kali computer and scroll up, as you can see, we captured a login that was sent to this website, testhtml5.vulnweb.com. Again, this is exactly the website that we have here. And if you look in here, you can see that the username was Zaid Sabi and the password was 123 all the way up to 90. So basically the idea that I'm trying to get across right now, anything that the target computer sends or receives right now will be captured by the Kali machine. And like I said, we can do this to any computer or any phone that is connected to the same network as us, whether it's a Wi-Fi or a wired network.
Nếu bạn thấy là cái module snip của BetterCap nó có chức năng sniffing giống như là WhatsApp, và chúng ta xem được rất nhiều dữ liệu mà không mã hóa. Dù cái trang này không mã hóa thì chúng ta có thể xem được thậm chí cả username, password mà tác giả gõ vào. Giờ chúng ta nói sang Caplit, cái tính năng script ở trong BetterCap. Và chúng ta nói về cái việc mà tạo ra các kịch bản, đúng không? Ở trong BetterCap, thay vì chúng ta gõ từng lệnh thì chúng ta có thể đưa vào một script để chạy tự động.
In the previous lectures, we learned how to use BetterCap to discover all clients on the same network, run an ARP spoofing attack to intercept the data, and then sniff data to see the usernames, passwords, and everything that getting sent over the network. Now, in order to do this, we actually had to run a number of commands. So first of all, we had to do net.probe on to turn on the probe module. We had to set the settings for the ARP spoof module, turn that on, and then turn the sniffing module on. Now, every time you want to do this, every time you want to intercept data and see it on screen, you're gonna have to do all of the steps that I showed you in the previous lecture. Or, if you're lazy like myself, you can use a caplet to do all of that automatically, which is exactly what I want to show you in this lecture. So, what do I mean by a caplet? Well, basically, a caplet is just a text file that contains all of the commands that you want to run. So, I'm going to resize this menu. I'm going to open a text file. And I'm just going to organize this a little bit to make it easier to follow. And I'm going to clear this window here. And I'm going to go to the first command that we had to run in order to do this. So again, scrolling up, the first thing we did was net.probe on. So in my text file here, I'm going to literally type this command, net.probe on. And as we saw, this will automatically start the net.recon module. Again, we enabled both of these modules in order to discover the connected clients and keep automatically discovering any new clients that connect to the network. The next thing that we did was modify the settings for the ARP spoof module. So we did set ARP spoof full duplex to true. I'm going to actually copy this and paste it here. Then we set the target IP. So again, I'm just going to copy this and paste it here. And keep in mind, this is very important. You want to make sure that you change the IP here to the IP of your target all the time. And if you are targeting multiple computers, you can just use the comma and type the next IP after the comma. Next, we turned on the ARP spoof module. So again, this is what I'm going to do here. I'm going to do ARP.spoof on. And finally, we also ran the sniffer by doing net.sniff on. So again, I'm just going to type this in here, net.sniff on. So this is actually a nice summary of what we did in the previous lectures. Again, like I said, every time you want to intercept the connections, you're going to have to start BetterCap and run all of these commands manually. You want to start the probe module. You want to enable the full duplex, so you fool or spoof the target and the router. You want to set your target IP, and you want to turn on the spoof and turn on the sniff. So, to make this very easy, instead of having to type this every time we want to run an ARP spoofing attack and intercept data, I put all of this in a text file. I'm going to save this text file. I'm going to put it in my root directory, and I'm going to call it spoof.cap. So I'm going to save this now, and I can close it because we're done with it. And we can go back here. And what I'm actually going to do, I'm going to exit out of this. So I'm going to quit BetterCap, and I'm going to clear the screen. And if I do ls to list all of the files and directories in the current working directory, because right now I am in root. So if I do ls, you can see we have a new file called spoof.cap. And just to confirm, if I go down to my file manager right here, you can see we have a new file again in the root called spoof.cap. And all we want to do is feed this spoof file to BetterCap before we start BetterCap. Now, we don't know how to do this, so we're going to do BetterCap -- help to see all of the options that we can set with BetterCap. And what we want to do is use the dash caplet option right here. So we're going to run better cap like we used to do. First of all, we do better cap, followed by iFace to specify the interface that is connected to the target network. And in my case, this is ETH0. So far, this is identical to what I've been doing in the previous lectures. The only difference now is we're going to use the dash caplet option to specify my caplet file that I just created. So I'm going to do dash caplet, followed by the file that I just created, which is called spoof.cap, and that's it. Now, before I hit enter, just to confirm to you, I'm going to go back to my Windows machine, and I'm going to do ARPA just to show you. And as you can see right now, the router's IP right here has this MAC address. So after I run this, it should automatically start all of the modules that I just typed, and it should run an ARP spoofing attack. Therefore, the router's MAC address should change to the MAC address of ETH0 that is connected to Kali right here. So I'm going to hit enter. And as you can see, we actually got an error, and the error saying the caplet spoof could not be found. So I'm suspecting I made a spelling mistake, and I did. As you can see, I actually named the caplet soof, not spoof. So I actually make a lot of mistakes like this. So I'm just going to rename this to spoof, and we're going to go back here. I'm going to exit and run the same command again. And perfect, as you can see, we got no errors at all. If I do help, as you can see, automatically we have the spoof is running. We have the probe, the recon, and the sniff all running as soon as we ran better cap. If you remember, the first time we ran it, we only had the stream running, and we had to do everything manually and set the options manually. So this is a really, really nice way of doing it.
Cái event stream này nó là cái tính năng thông báo tất cả những sự kiện ở trên màn hình console. Khi các bạn chạy Bettercat thì bạn thấy là nó chỉ như tay snip lưu lượng ấy, thì nó sẽ hiển thị. Nếu mà chúng ta bật cái event stream này lên thì nó sẽ bật tính năng để hiển thị trên cái console để chúng ta xem. Nếu mà không bật này thì nó sẽ nó không hiển thị những cái lưu lượng của chúng ta như snip rồi.
Now, let's confirm that everything is working as expected. So I'm going to go to the Windows machine, and we're going to do ARPA again. And perfect, as you can see, the router's MAC address has changed to the same MAC address as the Kali machine. And the original router's MAC address, the correct one, was this. So this means that this Windows machine is now spoofed, thinking that the Kali machine is the router, and the router now thinks that the Kali machine is this machine. This will place Kali in the middle of the connection. And just to confirm this, just real quick, I'm already in VulnWeb. This is the website that we tested the login before. I'm actually even still logged in, so I'm gonna log out, log in again, and I'm gonna leave the username to admin, and I'm just gonna put a password again, 1234290, enter. Let's go back, and perfect. As you can see, we wouldn't be able to get this if we were not in the middle of the connection. So the fact that we're getting all of this information means that we managed to intercept the data and see everything the target user sends or receives. And again, we have the username and the password right here. Like I said, this will only work with HTTP. We will discuss HTTPS in the next lectures. But in this lecture, I just wanted to show you an easy way of scripting the commands that you often run with BetterCap. Because in the future, we're going to be doing a number of things that rely on us being the man in the middle. So, because I don't want to waste time enabling all of the modules that we're running here. So again, if I right click this and open with a normal text editor, all you'll have to do is just put your commands in a file, give a file a specific name, and then when you run BetterCap, all you have to do is just use the.
Như vậy các bạn thấy là ở trong cái video này thì chúng ta thấy là chỉ việc đặt tất cả những cái lệnh cần thực hiện BetterCap vào trong một cái file text, và chúng ta dùng cái tham số caplit khi mà chúng ta chạy BetterCap và xác định cái đường dẫn đến cái file mà chứa cái kịch bản mà chúng ta muốn chạy, thì nó sẽ gõ tất cả những tự động thực hiện tất cả những cái lệnh mà chúng ta muốn thực hiện trong cái file đó. Còn cái interface này là xác định cái giao diện mà các bạn muốn chạy BetterCap. Bình thường thì nó sẽ sử dụng cái giao diện mặc định mà các bạn đang kết nối internet. Còn nếu chúng ta muốn xác định chính xác cái giao diện nào thì các bạn gõ tên của giao diện nào, ví dụ ở trong Kali Linux thì cái F0 này chính là cái giao diện bằng LAN này. Còn nếu mà mạng không dây thì nó thường tên là WLAN 01 vân vân.
Caplet argument followed by the name of your caplet file.
Đây là cái kịch bản đưa vào trong BetterCap. Còn thời gian chúng ta sẽ nói thêm về HTTPS.
Now, everything that we did so far will only work against HTTP pages. The reason why it works against HTTP because, as we've seen, the data in HTTP is sent as plain text, so it's text that humans like us can read and understand. That's why when we're the man in the middle, we're able to read this text, and if we wanted, we're able to modify this text as we wish. Now, this is obviously a problem, and this problem was fixed in HTTPS. So, as you know, most websites use HTTPS. The reason why, like I said, because it's a more secure version of HTTP, and basically the way it works is it adds an extra layer over HTTP, which is where the S comes from. So it's a secure HTTP protocol, and this extra layer will encrypt the plain text data that HTTP sends. So if a person manages to become the man in the middle, they will be able to read this data, but the data will be gibberish. It will not be readable to the person intercepting the connection. Now, HTTPS relies on TLS or SSL to encrypt the data, and this is very difficult to break. Therefore, in order to bypass this, the easiest method is to downgrade HTTPS connections to HTTP. So, since we're the man in the middle, we can check if the target is requesting a HTTPS website, and instead of giving him the HTTPS version of that website, we will give him the HTTP version. This way, the data will be sent in plain text, and we'll be able to read it exactly as I showed you in the previous lecture. To do this, we'll have to manually configure and use a tool called SSL strip, and I show how to do this in my more advanced courses. But luckily, BetterCap has a caplet that'll do all of this for us. The only problem is, this caplet does not replace all HTTPS links to HTTP in the loaded pages. So I modified this caplet for you to make sure that it's going to work as expected, and I've included it in the resources of this lecture. So all you have to do is download the zip in the resources of this lecture, and I have it downloaded in my Kali machine. So I'm going to go to my files and to my downloads, and I have it right here. It's called hstshijack.zip. I'm going to right click it and extract it here. This is the folder of this caplet, and I'm going to copy it and paste it in the correct location where BetterCap loads caplets from. So to go to that location, you can either press Ctrl and L on your keyboard to open the path bar, or you can press here and press a / again to open the path bar. once the path bar is open, we want to go to USR, share, BetterCap, caplets. So like I said, this is the default location where BetterCap stores all of the caplets. I'm going to hit enter. And as you can see, we already have this caplet in here. But like I said, this caplet is buggy. It doesn't work as expected. So I'm going to delete it. So right click, move to trash. And I'm going to paste the one that I just copied in here. So that's it, we're good to go. We can go ahead and use this caplet from BetterCap. But before we do that, I also want to go to my home directory. This is where I stored the caplet that we created in the previous lecture, the spoof caplet, the one that will run the ARP spoofing command and then run the sniffer. And I just want to modify one thing in this. So I'm going to right click it and open it with LeafPad. And what I want to modify is I want to add an option to the sniff in here. So as you know, this line net.sniff on will turn on my sniffer, but before turning it on, I want to set the net.sniff.local to true. And what this option will do, it'll tell BetterCap to sniff all data, even if it thinks this data is local data. The reason why I set this option to true, because once we use the HTTPS bypass caplet, the data will seem as if it's being sent from our computer. So BetterCap will think these passwords belong to me, to my computer, and it will not display it to me on screen. That's why we're setting it to true, so that we can see all the usernames and the passwords sent on the websites that we will downgrade from HTTPS to HTTP. So I'm going to save this, Control S, and quit it, Control Q. And now we are actually ready to go and use this caplet. So in the next lecture, I'm going to show you how to use this caplet to downgrade HTTPS connections to HTTP and therefore be able to sniff the URLs, the login information, and passwords that people enter on websites that use HTTPS by default. And press a / again to open. And I have it downloaded in my Kali machine. So I'm going to go to my files, the loaded pages. So I modified this caplet for you. It has a caplet that will do all of this for us. The only problem is this caplet does not replace all HTTPS links to HTTP in the loaded pages. So I modified this caplet for you to make sure that it's going to work as expected, and I've included it in the resources of this lecture. So all you have to do is download the zip in the resources of this lecture, and I have it downloaded in my Kali machine. So I'm going to go to my Okay, so now that we understand the theory behind bypassing HTTPS and we have the correct caplet placed in the correct path, let's go ahead and use this caplet with BetterCap and see how we can downgrade HTTPS to HTTP and steal passwords from login pages that use HTTPS by default. So I'm going to go to my terminal and I'm going to use BetterCap exactly as I've been using it before. So we're doing BetterCap, the name of the program. We're giving it our interface after the iFace argument. We're using the caplet argument to specify a caplet to run as soon as we run the program. And we're running the spoof caplet, the one that we built in the previous lecture, that will run the ARP spoofing command and run the sniffer for us. So I'm going to hit enter. And as you can see, everything got executed as expected. If we do help, we'll see all the running modules, and we have the ARP spoof and the sniffer running with the recon and with the probe. So this is exactly what we wanted from our caplet. The next thing that we want to do is run the HSTS bypass caplet, the one that we just downloaded and placed in our BetterCap directory. So first of all, the HSTS bypass caplet is one of many caplets that BetterCap comes with. If you want to list all of these caplets, you can do caplets.show, and as you can see, you'll get a list of all of the caplets that you have and their location on the system. Now, the caplet that we want to run is the HSTS hijack caplet, this one right here. And you can see it's stored in here. This is the location where we actually replaced it with the one that we downloaded. And to run any of these caplets, all you have to do is literally just type its name. And as usual, you can use the tab to autocomplete. So to run our caplet right here, all I have to do is literally type HS and press tab. And as you can see, it will automatically autocomplete for me and type the caplet name. Now, if I hit enter, this will load the caplet with all of its options and it will run it for me. So as you can see, because we don't see any errors, this means everything got executed as expected. So let's go to the Windows machine, browse some HTTPS pages and see if we can sniff data, usernames, passwords, and URLs that they enter on their computer. So I have my Windows machine here. I have Chrome installed. This is the latest version of Chrome at the time of recording this lecture, which is in April 2019. Now, a really good idea before trying all of these things is to remove your browsing data, because the websites that we're going to try to access might be cached and they might be just loaded from your cache. This will only happen if you're visiting the same website over and over again, mostly when testing. Therefore, it's a really good idea to Control-Shift-Delete and click on clear browsing data. Make sure all of this is clicked, make sure it's set to all the time, and click on clear to remove all of it. And let's go ahead and go to a website that uses HTTPS. So a good example would be linkedin.com. And perfect. If you look here at the top, you'll see the website is loading over HTTP, not over HTTPS. Therefore, we'll be able to see anything the user enters in these boxes. So let's put a username. Let's set it to zaid@zsecurity.org. And I'll put a password as 123456789. It doesn't really matter. You can use any password. And I'm going to hit enter to log in. This is wrong, so obviously we're getting an error message. But if we go back to Kali, as you can see, we're capturing all of this data because it's not being sent over HTTPS anymore. It's being sent over HTTP. And if you look in here, you can see we captured login information. It's sent to linkedin.com. Sent to this specific URL, a login URL, and you can see the username is zaid@zsecurity.org and the password is 123 all the way up to 90. So that's really good. Let's go ahead and test another HTTPS website. Let's go to stackoverflow.com. Again, you can see on top it's loading over HTTP, not HTTPS. So I'm going to click on login. And again, I'm going to put my email, zaid@zsecurity.org, and we'll put a password as 123456789. Hit enter. And let's go to the Kali machine again. Scroll down this time because we're stuck on top. And perfect. You can see we have a post request in here. It's sent to this specific URL. Again, you can see login in the URL. You can see the website itself, stackoverflow.com. And if we scroll down a little bit more, we can see that the username is zaid@zsecurity.org. And the password, again, 123 all the way up to 90. So that is really good. Now we can downgrade any HTTPS connection to HTTP as long as the target website uses HTTPS, not HSTS. So this method will work against pretty much all websites that use HTTPS. except for the really popular websites such as Facebook, Twitter, and so on. So let me show you a quick example. If I go here and try to go to facebook.com, you'll see that the website got loaded over HTTPS, not over HTTP, even though we configured our caplet correctly, and even though we're able to downgrade HTTPS connections on a lot of websites such as LinkedIn and Stack Overflow. This is happening because Facebook is using HSTS, which is a little bit trickier to bypass. In the next lecture, we'll talk more about what HSTS is, why it's tricky to bypass, and how to partially bypass it and still get usernames and passwords from the websites that implement it, such as Facebook, Twitter, and so on. .show, and as you can see, you'll get a list of all of the couplets that you have and their location on the system. Now, the couplet that we want to run is the HSTS hijack couplet, this one right here. And you can see it's stored in here. This is the location where we actually replaced it with the one that we downloaded. And to run any of these couplets, all you have to do is literally just type its name. And as usual, you can use the tab to autocomplete. So to run our couplet right here, all I have to do is literally type HS and press tab. And as you can see, it will automatically autocomplete for me and type the couplet name. Now, if I hit enter, this will load the couplet with all of its options and it will run it for me. So as you can see, because we don't see any errors, this means everything got executed as expected. So let's go to the Windows machine, browse some HTTPS pages.
Các bạn thấy là ở đây cái cabinet HSTS này thì nó có tác dụng là khi mà chúng ta vào những cái trang web này thì nó sẽ thay thế ví dụ như là cái phiên bản mã hóa bằng phiên bản không mã hóa. Cái giao thức bình thường người ta sẽ vào cái trang mà nó có HTTPS thôi, thì cái này nó sẽ downgrade, tức là nó sẽ downgrade từ HTTPS thành HTTP để cái người dùng người ta sẽ vào trang HTTP. Bây giờ chúng ta hình dung là cái máy này nó vẫn là máy manage middle, đúng không? Nó vẫn là cái máy để chuyển các gói tin từ nạn nhân đến cái trang web mà người ta vào, đúng không? Thì bây giờ nó thay cái phiên bản HTTPS bằng phiên bản HTTP và người dùng thường nó không để ý là cái trang đó nó không mã hóa và vẫn nhập username password để cho nó có thể bị capture được.
And see if we can sniff data, usernames, passwords, and URLs that they enter on their computer. So I have my Windows machine here. I have Chrome installed. This is the latest version of Chrome at the time of recording this. All of this is clear and perfect. Add
cái trang
zsecurity.org.
này đúng không? Thì có thể là
and I'll put a password as 1, 2,
nó có cả
3,
phiên
4,
bản
5, 6, 7,
mã hóa và không mã
8, 9,
hóa.
0. It doesn't really matter. You can
Thì
use
cái
any
module
password. And
module mà chúng ta vừa nói HTTPS trong HTTPS là nó ép buộc downgrade về phiên bản không mã hóa. Không mã hóa đấy, có thể là cái not secure này là không mã hóa đấy. Tuy nhiên thì có những trang web mà nó có tính năng bảo vệ tốt, ví dụ như là Facebook, thì chúng ta không làm điều đó được. Facebook thì nó vẫn sử dụng cái giao thức mã hóa, mặc dù đã dùng cái module highlight test ở trong cái tờ test vẫn không thành công, bởi vì nó có tính năng kiểm tra xem là cái giao thức là gì. Nên chúng ta không thể
In the
đây là
previous
hacker
lecture,
của chúng ta.
we've seen how to
Hacker không
downgrade
thể ép buộc
HTTPS
sang cái phiên bản của
websites
hóa.
to HTTP, and this allowed us to basically see anything a user does on these websites because data in HTTP is sent in plain text. This is the configuration file, future lecture. Finally, you want to make sure that the DNS spoof domains are set exactly the same as the replacements in here. As Chrome right here, .com got replaced with facebook.com. Look on the video in the resources of this lecture. It will show you exactly how to fix this issue. Now,
Nếu các bạn thích thì buổi sau chúng
with
ta sẽ xem
Facebook
tiếp
contains code
cái
normal
video này.
text file. Now, I'm
Hơi lớn
actually,
nên
like
thầy
I
không gửi
said,
qua
check
mạng được.
this using the note. You can add an. Perfect.
Bây
As you can
giờ
see,
đang
we
nghỉ
have
á.
the usernames. Anything us, it will always send it in HTTPS, and it will always only accept it if it comes back as HTTPS. So there's nothing we can do really once we become the man in the middle, because the browser is doing this check locally. It's checking this against a list that is stored on the computer itself. Therefore,
Hôm nay thì thôi chúng ta không điểm danh nữa, thầy cũng không học được cái gì. Nếu không thì các bạn muốn điểm danh thì thầy sẽ share cái này lên một cái